Assalamualaikum warahmatullahi wabarakatuh and hello everyone. My name is Mohamed Lokman bin Jalaluddin. I'm from Faculty of Manufacturing Engineering. Today I'm going to present my final year project. The title is Recycle Glass and Carbon Fiber by Mechanical Process for Concrete Composite. My supervisor named Dr. Shariza binti Ismail and my panel is Dr. Muhammad Idirozi bin Abdul Manaf. My second panel, Dr. Jaria binti Muhammad Joy, and my third panel, Dr. Intan Syarhidah binti Osman. Okay, here is my presentation flow. First of all, I'm going to explain my problem statement, then objective, then methodology, besides results and discussion, and finally, I'm going to explain conclusion. Okay, the problem statement for my project. First, without adequate knowledge. Use these composite materials easily without adequate knowledge of disposal procedure. Second, end up throwing. After the end of the composite material, usually people may end up throwing to the rivers, planted or sending waste to the landfill. Lastly, high cost. High cost of sending waste to landfill and natural quality charge per kilogram, which is 10 ringgit per kg. Composites are mixing two or more parts of thin solid and robust material, are sustainable perfection but a recycling challenge. Okay, now we move to objectives. There are three objectives for my research. First, to study the recycling of carbon fiber and glass fiber by the mechanical recycling process. Second, to produce the concrete composite using the recycled carbon fiber and glass fiber by mechanical recycling process. Lastly, to characterize the properties of recycled concrete composite. Okay, here is my methodology. First, start, then mechanical recycling, then shredding, grinding, concrete composite, mechanical testing, which is comprehensive testing, then analysis the recycled carbon fiber and glass fiber on concrete composite with SEM, which is scanning electron microscope, and XRD, X-ray diffraction, then lastly data analyze. Okay, now I'm going to explain mechanical recycling. As you can see, there is the recycled glass fiber and recycled carbon fiber. So cut the recycled glass fiber and carbon fiber into small pieces. So the first step is shredding. Shredding the recycled glass fiber and recycled carbon fiber composite material into 50 to 100 mm in small pieces using shredding machine. Okay, next is grinding process. Using the grinding machine, broken down the material into 10 mm to 50 micrometer pieces. Okay, now we move to concrete composite. First of all, prepare 3 containers to produce normal concrete, concrete with recycled glass fiber, and concrete with recycled carbon fiber. For normal concrete, mix water, cement and sand with the ratio of 1:2:3. Besides, for concrete with carbon fiber and concrete with recycled glass fiber, mix water, cement and sand with the same ratio of 1:2:3 and then add 8% of recycled carbon fibers and recycled glass fibers in relationship to cement mass as shown in the table. Then pour the normal concrete into a mold of shaped cylinder which measuring of diameter of 100 mm and height of 150 mm to keep the concrete in place until it has been set and push it so that it fill the space. Pour the concrete into recycled glass fiber into a mold of shaped cylinder which measuring a diameter of 100 mm and height of 150 mm to keep the concrete in place until it has been set and push it so that it fill the space. Lastly, repeat the same steps to concrete with recycled carbon fiber. Okay, before moving to the mechanical testing, the concrete must be curing. As soon as the concrete is hardened and lasts for at least 7 days, cure should be begin. Okay, now mechanical testing for concrete composite. There was one mechanical testing that was carried out in this research, which was compressive testing. The experiment undertaken in this analysis adhere to the ASTM C39. As you can see in the figure shows the compressive testing machine which maximum stress at 100 kN. Determine the fracture type and then enter the load and fracture type. Okay, now I'm going to explain results and discussion. First of all, visual observation. As shown in the figure, the recycled glass fiber and recycled carbon fiber in microscale size after the grinding process. Besides, after the grinding process, the recycled glass fiber and recycled carbon fiber in microscale size mixed together with water, cement and sand to make the concrete. Okay, as you can see inside the figures, as shown the normal concrete with recycled glass fiber and concrete with recycled carbon fiber successfully formed in good surfaces and good condition. But the surface of normal concrete had a good surface, while the surface of concrete with recycled glass fiber and concrete with recycled carbon fiber had slightly poor on the surfaces. This is because due to do not press correctly the concrete in the mold to make it smooth surfaces. Okay, now we move to analysis of the compressive properties. As shown on the figure, the stress versus strain of normal concrete with recycled carbon fiber and concrete with recycled glass fiber. From the graph, stress versus strain, the ultimate tensile strength and Young's modulus of each concrete calculated. The ultimate tensile strength for normal concrete is about 8.20 megapascal, while the ultimate tensile strength for concrete with recycled carbon fiber is about 4.62 megapascal. Besides, the ultimate tensile strength for concrete with recycled glass fiber is about 9.06 megapascal. The largest increase of ultimate tensile strength is about 10.49% at concrete with recycled glass fiber addition compared with normal concrete. It has been found that a greater adhesion between the concrete and the recycled glass fiber. In addition, the microscale size of recycled glass fiber had good bonding with concrete when a stress is being applied. Hence, the tensile modulus and strength are greatly improved due to this beneficial interaction. Furthermore, there is a sharp decrease in the ultimate tensile strength when compared with normal concrete with carbon fiber, which is about 56.34%. This is because the microscale recycled carbon fiber did not have a good bonding with the concrete. Okay, from the graph also we can calculate Young's modulus. The Young modulus for normal concrete about 4.50 megapascal. The addition of concrete with recycled glass fiber results an increase in the Young modulus, before decrease afterwards the addition of concrete with recycled carbon fiber. The trend was similar with the ultimate tensile strength attribute. Okay, the highest Young's modulus was found at about 6.92 megapascal, which belongs to the concrete with glass fiber. The favorable improvement value was increased at about 53.78% compared than the normal concrete. This is because the presence of silica in recycled glass fiber very strong bonding with the silicon dioxide which was present in the concrete. The lowest Young's modulus was detected from the sample concrete with recycled carbon fiber, which is 3.80 megapascal. There are almost 15.56% reduction as compared to the normal concrete. The properties drop might due to the improper bonding with the concrete. In addition, carbon atom in recycled carbon fiber did not adhesive with the silicon dioxide in the concrete. After done the compressive test, analyzed and recorded the cylinder fracture type. So from the figure shows the normal concrete after compressive test. For normal concrete, it shows type 2, which is well-formed cone on one end. There are some vertical cracks running through caps and no well-defined cone on other end. Fracture type for concrete with recycled glass fiber shows type 1. The concrete with recycled glass fiber is reasonable well-formed cones on both ends. In addition, as shown in the figures, for concrete with recycled carbon fiber as shown, fracture type 5. The type defines side fracture at top because it occurs commonly with unbonded caps. Okay, now we're going to results and discussion for analysis of SEM, scanning electron microscopy. As shown in the figures, the micrograph of normal concrete sample. From the micrograph, it was clearly shown that there were not any foreign objects present in the mixture. The weak interface was resulting lower strength of the concrete. Other than that, there are some poor bonding that becoming a weak point when applied a stress. Okay, as shown in the figure shows the concrete with recycled glass fiber. This proves that the presence of sand in concrete and the recycled glass fiber interface are stronger, which promoting a better result strength. Other than that, a good dispersion of recycled glass fiber in concrete was found, which tends to give high strength and good bonding. Lastly, as shown in the figure, the concrete with recycled carbon fiber. This figure proves that the presence of sand in concrete and the recycled carbon fiber interface are not strong enough. Okay, now I'm going to explain analysis of XRD, which is X-ray diffraction. Okay, as you can see on the figure, shows the XRD spectrum of normal concrete. For normal concrete, the crystalline structure at the near to 47.45 degree in normal concrete, the presence of silica or silicon dioxide were little, so that it was not strong bond enough interface between them. Besides, as shown in the figure, the XRD spectrum of concrete with recycled carbon fiber. XRD patterns of silicon oxide had two peaks at 2 data, which is equal to 36.12 degree and 47.63 degree due to the 2 degree plane. Okay, in concrete with recycled carbon fiber, there were a few present of silicon oxide, so that's why carbon atom in recycled carbon fiber did not adhesive with the silicon dioxide in the concrete. In addition, the figure shows the XRD spectrum for concrete with recycled glass fiber. It produced many peaks. Okay, this proves that the presence of silica or silicon dioxide in concrete with recycled glass fiber. In such way, the bonding between silicon dioxide in recycled glass fiber and concrete was strong, and therefore it has strong strength. Okay, now we're moving to conclusion. The first objective of this research is to study the recycling of carbon fiber and glass fiber by the mechanical recycling process is successfully achieved. The second objective of this research is to produce the concrete composite using the recycled carbon fiber and glass fiber by mechanical recycling process is successfully achieved. Okay, lastly, the bonding surface morphology and the crystallography structure of normal concrete, concrete with recycled glass fiber, and concrete with recycled carbon fiber were observed through scanning electron microscopy and X-ray diffraction respectively to meet the last objective, Lastly, we're going to see recommendation. In the future, use recycled glass and carbon fiber by chemical process for concrete composite. Second, to ensure that this composite is appropriate for the building sector, it must be studied further to test certain durability qualities, including permeability of water and permeability of gas. Thank you for watching my presentation.